Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Now, before we proceed, I kind of like to request our members to subscribe, engage us in the comment section, and also ring that notification bell for more updates on various topics under discussion. Now, in this particular discussion, I'm going to look at the concept of the variance. And of course, this is going to be a culmination of the different types of measures of dispersion which are looked at in our previous video. In this case, basically defined the concept of dispersion or variation as a spread of data about a specific average. And in this case, I'm going to perhaps put it in this particular description. So I'd say basically that we have defined the concept of variation or dispersion as the degree to which the numerical data is going to spread about an average value. And of course, this is going to give us a clue on the concept of variance. In this case, we are going to be biased on basically the concept of population variance. And later on, we shall look at the second case, of course, from the concept of a sample, whereby we're going to create a relationship between the two. Now, from the different types of dispersions, which basically I mentioned from our previous discussion, I said that we're going to look at different types of dispersions, whereby we had mentioned the concept of a range and a relative range. And then we had looked at the concept of the quartile division, and the coefficient of a quartile division. Just going to put it in this summary form so that the space is enough. So we had also looked at the concept of the mean deviation, and the coefficient of a mean deviation in that specific respect. And in this case, these are going to be various measures of dispersions which we are discussed. And as we can see, there is consistency in this specific aspect of the spread or the degree of course, the dispersion of this specific type of data from an average value that we're going to define. And in this case, I looked about the concept of the mean deviation about different averages of the mean, mode, and median. And of course, I'm going to put a link of these specific videos in our description box. And lastly, we shall look at the concept of the standard deviation as a measure of the types of course, dispersions which we had mentioned. And of course, the coefficient of variation, which is going to form our last bit of these different types. In this case, we are going to look at this consistent kind of a concept of dispersional variation, which is going to be appearing in terms of our population given as our topic of discussion today. So therefore, we are going to look at the population variance. And before we proceed, of course, I'd like to remind us of the concept of a few terms which we had discussed, of course, in our previous video, whereby we had basically mentioned that we are going to come across various terms under the product topic of statistics. And one of the terms, of course, we had mentioned, of course, is a statistical population, or a population, whereby we had said that this is going to form a range of all the possible observations, of course, which are going to be of a specific characteristic of an interest or a characteristic of interest, which are going to be under investigation. So in this case, this is going to form what we refer to as a population. And in this case, apart from that, we had spoken about the concept of a sample. And we said that this is going to be a subset of so this is going to be a subset of the population, which is going to be obtained from a sampling technique. And this, in a way, is going to represent the various, or rather, all the observations of a population in a sense. Therefore, this is going to be a representative aspect of the population referred to as a sample. So in a summary form, these are some of the terms which we had mentioned. Of course, as we go ahead, I'm going to mention others which are going to be relevant for us in our discussion. And in this case, we are going to look at the specific variation of this concept of a population, which have, of course, defined as all the possible characteristics of a specific set of a sample under investigation. And of course, we're going to look at that one using a particular a general representation in terms of a formula. Now, if we are trying to look at a specific sample, and I mentioned the concept of variations from the specific average, which we are given in terms of the mean, the mode, and of course I had spoken about the median. So we said that this we're going to give them in terms of absolute value, and this is going to be a deviation from the mean, and the second one is going to form a deviation from the mode, and the last one is going to form a deviation from the median, given in that specific order. So in this case, if we try to look at those specific deviations, if we divide the specific variation by the number of values in that specific population, we're going to obtain what we refer to as the population variance. Now, of course, this is going to be unique in a way that it's going to be a square of the variations, whereby we're going to represent the population variance in terms of this specific symbol, which is going to be given as a square, as we said, the square deviation from the mean given as such. And this is going to be given in terms. So we have said in a sense from that particular statement that it is going to be obtained by the number of values of that particular population, or we divide the variation by the number of values of that specific population. And of course, we have talked about this specific concept of this variance being an average square deviation given in terms of so this n is going to represent, so we have said we divide by the number of these specific values in the population. So we're going to give that number in terms of n. So by division, I've given it in terms of course, a reciprocal of 1 over n. And then we're going to find the total number of these specific variations by having it as a general case for the averages given as such, and this is going to be a square of those specific variations given as such. So this specific representation is going to represent our population variance, and we're going to see that we can consider the case of these specific observations ranging from 1 to the total number of course, values of that specific population given in terms of n. Now, we can consider this one for a frequency distribution, whereby we are going to factor in the concept of what we call the frequency. So for a frequency distribution, we can define the concept of a population variance given in terms of that specific representation. And of course, that's going to be divided by the number of course, values in that particular population given as 1 over n, and then we shall have the summation of the product of frequency given together with the square of that variation given as I've done it above as such. So that's going to represent the population variance from a frequency distribution perspective, and of course that's going to form our general representation for the first case for a specific type of data and for a frequency distribution given as such. And in this case, of course, it's going to be considered for, as I've mentioned. Now, from a frequency distribution, we're going to use the concept of classes. So K, therefore, is going to represent the total number of classes given in that specific case. So therefore, as we go ahead, we're going to be treating the concept of variance, is particularly for population variance, using these two specific representations, which are going to form a basis for a discussion on other aspects related to the variance insofar as population is concerned as we go ahead. So kindly check our discussion boxes for various links of other similar videos, and they're going to assist us, of course, do an evaluation of various aspects of variance under the product topic of statistics. So that is it for now, guys. Bye. God bless you. Catch us in our next video.